security at Mozilla. For anybody who doesn't know Mozilla, we are the company that makes Firefox, amongst a bunch of other interesting things. So in particular, my area is to work on helping Mozilla's developers to build secure applications, as well as to lead a team of developers that builds new security automation tools so that in addition to supporting our developers by helping them test and assess the security of their software, we're giving them the tools to be able to do that testing themselves and to integrate it into the lifecycle. Now, the thing is web security is kind of getting a little boring and stale because every time somebody shows off a new tool, it's a new way to do intercepting proxy work or be able to crack a particular type of hash or anything like that. But the problem is that web development has changed quite dramatically in the last few years. And a lot of people in the security industry haven't really caught on to some of the significant changes that are coming down in terms of what browsers support. Very few web security folks that I have met and interacted with in the industry are aware of things like WebSockets or Speedy or the impact of how those work within the server. And they're certainly not aware of things like WebRTC and some of the other more modern web technologies. So before I jump in and talk about what it is that we do to handle security at Mozilla, I'm going to show off a couple of things that Mozilla has been working on to kind of demonstrate how the web has changed. So a few years ago, when we released Firefox 4, we decided to show that you could actually write a really basic game in HTML5. So this was one of the very simple tech demos, and it totally doesn't fit on this screen, so give me a second. There we go. So this is pure HTML5. It actually has audio, but since I'm not plugged into the audio system, I'm not going to turn that on. And it's really simple. It's just your typical one-click game. And we just wanted to show that you could actually render stuff quickly and do some basic user input. And so people were like, ooh, that's a nice toy. And then didn't really do anything with web games. So we decided to push things forward a little bit further and say, okay, well, you can do more than just simple, cute little web games. You can actually create, let's hope it works this time. Yeah, there we go. You can create a very simple, trivial, web-based MMO, and this is actually all open source. This is running in the browser. If I happen to run into anybody else who's playing, it's actually running with other people playing in the same realm, has basic hitting, all of the capabilities you'd expect to see in a really basic role-playing game, and it's all running with multiple shards and everything. Everything's done in the browser with no special shims. It's only using standard web technologies. And people were like, okay, neat. That looks like something that we could have done in the late 1990s in Flash. So we decided to push the envelope a little bit further, and let's see here. This one sometimes takes a few seconds to load. So we have a really great tool chain that we use called Emscripten, and we have a bunch of people that work on contributing to that. And basically what we did is we decided to show people that you can actually run full-blown 3D video games, 3D shooters. This is actually being scaled down because of zooming, and it's also running with a bunch of other stuff concurrently in the browser. So let's see. For some reason, it's not actually allowing me to move, so I'm just going to reload that. Now, we recently worked with Epic Games to release a different technical demo. If you go to the Epic Games website, it takes quite a bit of time to load, but you can actually run an instance of the Unreal 3 engine within the browser. It's pretty cool, and it basically takes about 10 minutes of my presentation time to actually load it up. So if I have time at the end, I'll load it up and show you. While this is loading, I'll get on with the rest of my talk. So one of the key things and one of the big challenges that I have in doing my job at Mozilla is that it's the normal testing tools that you use for web apps, whether it's AppScan or WebInspect or basic intercepting proxy tools like Zap or Burp. They kind of fall down and die when you throw them in an application like this. They don't really do a whole lot that's helpful, and so we have a few different things that we have to tackle. So the other thing about being at Mozilla is that we're a not-for-profit organization. Sorry, I'm also using an HTML5-based slide presentation utility, so I have to make sure I switch to the right browser. So we're a not-for-profit organization. Pretty much everything we do is open source, not just Firefox. All of the server components for our applications that we write, everything, including Firefox OS, everything down to the radio software that's provided by the vendors, that's basically where we stop in terms of being able to release stuff as open source. We're a browser vendor, but we also have entered the cell phone market. And we have, the reason we're able to do some of the things we do as a not-for-profit is because we have an incredibly large contributor and supporter base. So in addition to having my team of security folks that work along the rest of the security group at Mozilla, which is about 30 people that are employed by Mozilla, and a larger number that are volunteers, that group has to support all of our core contributors, which is at about 100 people these days. And beyond that 100 people, we have all of the different people who make regular contributions in the form of supporting internationalization or people who file one-off bugs. So we have to make sure that those, we review each of those security issues that might get reported, or support our developers when they're trying to understand whether or not something has a security impact. And then as an organization, we work to support all of our casual contributors who basically go in and they might incidentally file a bug because they're getting a particular crash that's bothering them, or we have all the crash reports that come in. Whenever Firefox crashes, you get the little warning that says, hey, do you want to submit this? And if you do, that actually gets dumped into a database, and eventually somebody will look at it if it's something that is that we're not able to reproduce automatically. There's actually a whole system that's open source designed around that. Okay, give me 1 second here. I'm just having minor technical difficulties here. There we go. So the security community itself at Mozilla is split up into a bunch of different groups. We have, as I mentioned, about 30 different team members that work directly for Mozilla, and those are split up across people who are in my team that work on web security and security automation. We also have our platform security teams, which work on Firefox and Firefox for Android. And part of that platform team is our fuzzing team, which has a number of people who write some pretty powerful fuzzing tools that are designed around not just fuzzing Firefox as a browser, but also fuzzing JavaScript engines, fuzzing protocols like WebRTC and WebSockets and Speedy and all those kinds of things. Some of those fuzzing tools we've started to release, mostly our frameworks as opposed to the actual fuzzers themselves. And we are working to make sure that some of the other browser vendors have access to some of our tools. We announced earlier this year that I think it was at Black Hat that we announced that we were working on a shared project with RIM to release some of our fuzzing, share some of our fuzzing tools with them to help them get some feedback from our tools and vice versa, so that we could kind of do a little bit more collaboration. Ultimately, we'd like to get it to the point where our fuzzing tools are effective enough that we've managed to find all of the bugs that they're going to find so we can release them without introducing risk to our users. Beyond our security group, we actually have a group of people that we've recruited called champions. So we have 30 people. We have an organization that employs about 1,000 different people, and not just developers, but also line of business people, lawyers, HR folks, business development managers, and all kinds of different things that help beyond just releasing source code, all of the different, or releasing Firefox rather, all of the different things that we do. 30 people can't really support that large of an organization, especially when we're dealing with the entire body of contributors, as well as the community members that are looking for support or reporting issues, as well as doing additional research. So instead of trying to scale up and figure out different ways to get everybody in our team involved in all of these different things, we reached out into the organization and started to find people that were interested in security but didn't want to do it as their primary day job. So what we did is we worked with them to help them understand a little bit more about the security issues that affect their area, and made them responsible for determining whether or not we actually needed to be brought in on something. It's actually been extremely effective, and I'll talk a little bit more about that in a little while. We also have our security contributors, and in addition to how we typically get involved with developers in the open source community, we also have a bug bounty program. Our bug bounty was one of the first organized bug bounty programs on the internet. Fortunately, the bug bounty model has proven to be extremely successful and popular, to the point where Microsoft recently reversed their stance on bug bounties and started issuing them. And now there's a coalition of people of companies that have come together to fund something called the Internet Bug Bounty Program, which supports bug bounties for programs or for software and organizations that don't have bug bounties themselves. And then on top of of all of those people, we have a number of people that are working on security in different areas of Mozilla that we bring in as subject matter experts. So cryptography is a really important part of security, but it also is a discipline that requires a huge amount of dedicated time to develop a solid understanding of how not just how cryptography works, but also how cryptography can be done wrong. So rather than having all of the people in our team try to become multidisciplinary experts in security and cryptography, we just refer to all of the people that actually do cryptography as part of their day job, working on things like NSS and other parts of cryptographically sensitive components of Firefox and some of our services. We rely on them, we bring them into discussions, get them to support us when we need to make sure that something is being done properly. And they may not be formal members of the security team, but they have a significant set of responsibilities in that scope. So our security team is further broken down into our application security teams, operations teams, and our engineering team. And the difference in responsibilities are pretty straightforward. The applications folks are working on things that are either services we host or products that we ship. It's code that we've written at Mozilla that runs somewhere. Our operations folks basically keep all of our data centers up and running, set up all of our services, and manage all of those individual pieces. And our engineering folks work on new security features for things like Firefox. To a lesser extent, Thunderbird these days. We still support Thunderbird, and there are a few people that still work on Thunderbird, but we don't have a very large team focused on it anymore. It's mostly a community-driven project these days. So from our application security perspective, we have a group of people that work in, our teams are structured so that we have security reviews that get done on all of our different projects. And one of the things that we found is that as we were growing as an organization, I joined Mozilla in 2011, and there were, I guess, at the time there were a little bit more than 300 people when I joined, if I recall correctly. And then by the end of this year, we'll pretty much be at 1,000. So it's grown rather dramatically in the last few years. And we realized that not only are we developing more new projects, the pace of development increased really dramatically. And then a few months ago, the entire organization reorganized around having disparate teams for different responsibilities. So we'd have a UX team and a web team and a Firefox team, and then individual teams working on specific features. We reorged everybody into a product-focused organization. And so as a result, we now discovered that instead of having one UX team to work with, we had a UX team from each product group. We had a QA team for each product group, and each of those product groups has their own websites and services that they need to support, in addition to our websites and services group that's basically called our cloud services team now. They have an entire set of technologies that they're working on. If you may have heard of Persona, which is a federated identity system that Mozilla published, or that we released and have been building on since 2011. That's all done by our cloud services team. So we were in a position where suddenly we had way more projects than we could handle, and we had to move away from like the monolithic block all projects until we have a chance to do a security review, and we moved to a much more heavily risk-based review process. So we start with engaging with the individual teams to determine whether or not there's any an appropriate level of risk that we would want to do a code review. And the way that we do that isn't the typical way that an organization will look at it in terms of what's the impact to the business. We actually have a set of principles at Mozilla that govern how we make decisions about how we handle user data, that guide the business choices that Mozilla makes, and that's published in the Mozilla Manifesto. So we took a look through that manifesto, and we did include some elements of the business impact, but the business impact is really positioned in terms of Mozilla as a not-for-profit organization has this mission to push the open web forward and to keep user data safe, and to help, there's a whole bunch of little details about it, but ultimately we want to make sure that we have a positive impact on the web. So we had to restructure our risk-based review program in the context of that manifesto. So that initial engagement process is focused almost exclusively on understanding what the risk is to users of our applications, as well as what we need to do in order to continue maintaining the services and the products that we produce. Then from there, we'll jump directly into doing some code review if we determine that it's needed, so that we can identify whether or not we actually have to build out any custom testing. And then we include automated and manual testing for many of our applications. I'll talk a little bit about some of the tools that we're building around that. And of course, once we start, if we get involved early enough in the project, sometimes we'll try to include threat modeling in that. And especially for any significant high-risk services, we'll actually go out and build a complete threat model for the project. And one thing that I really enjoy about being at Mozilla is that I have the ability to publish all of the reviews that we do, as long as they're on Mozilla services. So I'm just gonna, we actually once we complete an individual review, we'll actually make sure we put it out there so that anybody who's using the service or anybody who wants to fork or stand up their own instance of the service can actually go ahead and just have a look at what risks we identified, the actual architecture of the process and the application, and all of the different threats that we've identified. So I kind of jumped ahead of myself a few minutes ago when I was talking about how we handle the engagement process around having security champions and whatnot. But basically, from an engagement perspective, the approach that we take is the initial approach that we went for was that we'd have individual team members embed with all of these disparate teams. Now, that seemed like a really good idea when I first started at Mozilla, because there was myself and one other guy doing web security work. So basically, we looked at the org chart and said, you take this half and I'll take this half. And so it was kind of a little bit challenging and unmanageable. And then we rolled out the Security Champions program. And so I mentioned that we've had some really good success with that. So we actually have several lines of business where the first point of contact for a lot of security things ends up being the security champion. Although we still get a notification whenever anybody wants a security review, we often have developers who are sitting there in meetings and they're participating, and the other developers don't realize that that person's actually the voice of the security team. So we've had cases where somebody's actually been hardcore advocating for security, and then somebody turns around and files a review request, not realizing that we're just going to turn around and go and talk to one of their team members, figure out what they think about it, and then add any feedback that we have. The upshot is as this program has become more successful, we started to learn a lot more about the different projects that are hidden under the floorboards. So there is a lot of interesting things that are happening at Mozilla. And the great thing about Mozilla, being a not-for-profit, meritocratic type of organization, is if you have a really good idea and you can spend some time on it, we actually have a program called Hatchery where you can basically take your idea, write a business case for it, and you'll get the resources. So if you need a massive cloud infrastructure, it's not a case of what's the revenue model for it. It's like, how cool is it? How cool can you make it look and sound? And then if you can do it, then the Hatchery folks will give you all the infrastructure. But they won't basically make you come and talk to us first to find out whether or not it's a bad thing that you get that. So that's kind of why we've had to go the direction of the security champions. Now, the really great thing about this program is that it focuses on individual contributors that are jumping in. Although we initially focused on those contributors being employees of Mozilla Corporation or Mozilla Foundation, we also decided early on when we designed the program that we would also encourage volunteers, not just volunteers from within the organization that want to participate, but volunteers from the community that want to learn more about security or take on more interesting challenges within an open source project. So one of the core concepts at Mozilla as an organization, and it was something that was really hard for me to get used to, is the fact that we don't distinguish, aside from some HR-related issues, between the role that a volunteer contributor can hold within the organization and the role of a paid employee. So we actually have some very interesting and high-impact projects that are being led by volunteers. That includes new features for things like Firefox, new websites and services. And we have, out of this pool of volunteers and contributors, we've also had some requests to support them in different ways in the community that have led to things like our affiliates program, our Mozilla representatives, and the ability to have, we basically built a micro-social networking site called Mozillians that actually allows for us to interact with and engage and give them access to some of our systems so that they can do really, really high impact changes and support the mission at Mozilla in more ways than just contributing code. And it's really cool that it goes beyond just people doing security reviews or just people making actual like writing code and submitting it for review. Our IT team, I think it was last year, launched a program where we actually have volunteer system administrators who have access to make significant changes and have a huge amount of trust placed in them by our organization. They're volunteers that just want to learn how to do this stuff and help out. So it's really neat. But it's also a bit interesting from a typical security perspective that you give somebody else outside of your organization basically keys to the kingdom. So it does make things a little bit twitchy sometimes. So the security champions often end up owning security for their areas, but we still expect them to come and talk to us when it's time to get any security testing done, and we want to make sure that when they're doing a review of an application that they're including beyond just the initial basic security checks that you'd like to see around authentication or making sure that there's input validation. We want to make sure that somebody has taken a closer look at the architecture of the application and figured out what exactly needs to be done for testing. From a testing perspective, we do all the typical stuff you'd expect to see. We use intercepting proxies. We like one in particular called Zap so much that last year we recruited the guy Simon Bennett, the lead developer for the project, to come and work at Mozilla. So he spends most of his time on implementing new features in Zap so that it can actually test modern applications. We also have a set of developer tools that are built into Firefox now. One of those is called GCLI or Gicly. And this is a really powerful, extensible framework. And there's, at AppSecUSA last year, Simon demonstrated some of the integrations that you can do, but we'll be releasing a new update to some of the tools that I'll demo later on that will actually allow you to drive a lot of these really flexible and powerful security tools directly from within the browser, including sharing state with things like an intercepting proxy. So you can actually inspect what's happening inside the browser from within the proxy and leverage the fuzzers and all of those other features that are built outside of the browser within it. And then this manual testing process with code review. And we have a bunch of other tools that we use as well. So we do fuzzing on a bunch of different things. On the platform side of things, we have a group of people that are focused on fuzzing, whether it's UX components or the front end of the browser, the JavaScript engine, all of the different types of multimedia interfaces that are exposed. And for anybody who's looked at WebRTC, there's a lot there. We have done a huge amount of work with our fuzzing team on that, and we're still looking to expand what we're doing there. Fortunately, that's shared code with other browser vendors, so it's not just us trying to verify the security of it. We have a number of internal tools, but we've also released a few different test harnesses, mostly in conjunction with the release of Firefox OS. We have Orangutan and ADB Fuzz. So ADB Fuzz is a test harness that's used primarily for setting up fuzzing jobs that run on Android, because we needed to be able to fuzz Firefox for Android. And then on top of that, Orangutan is basically a similar type of framework. If I recall correctly, the initial intent for Orangutan was to be able to fuzz some of the touch-based user interface elements of Firefox OS, but it can also be extended so that it can be used as a general application fuzzer, not just for Firefox OS itself, but for any Firefox OS-based applications. And then within my team, we have our security automation group. So we have, as I mentioned, we hired Simon Bennett, who works on Zed Attack Proxy. Since Simon has joined our team, in addition to improving the overall quality of the software, with the additional time and resources that he's had access to, he's been able to mentor some folks on implementing WebSocket support. So it's the first, it was the first. I think there's an additional proxy that supports WebSockets now, but it was the first one that could support WebSockets. And we're in the process of developing some additional support around Speedy so that you'll be able to actually use it for web applications that use that protocol instead. And for anybody who doesn't know what Speedy is, it's a protocol that was released by Google as part of Chrome a couple of, I guess, 2 years ago now, and has been recently being reviewed for inclusion as a standard in HTTP 2.0, which is important because it actually, as of some decisions that were made last week, it looks like HTTP 2.0 is going to be SSL or TLS by default, which is actually going to be a pretty big improvement. In addition to that, we have we released a tool called Garmer, which was a command line tool for implementing extremely basic web checks. So being able to test for things like header checks and being able to build individual use test cases so that you could do it in a repeatable fashion. The problem is, when I designed the tool, it was a rewrite of something that had been written by one of our QA folks, and it was written in Python, and writing tests in it was really easy if you know Python, but it also meant that you had to know Python. So none of our developers that were writing test cases in Node bothered using the tool. So we decided to move away from that, and in talking about it with Simon, he basically came back from Christmas holidays last year and said, hey, why don't we do this? And he created this JSON testing protocol, testing format, so that you can define as a JSON document a whole series of different types of security test cases, but it's more generally usable as a way of describing any kind of HTTP requests, any set of HTTP requests, as well as some of the operations that you want to perform on it. So you can actually instruct it from a file format level whether or not you want it to fuzz certain fields or how you want to have different types of interactions. Now the thing about it is it's built into Zed Attack Proxy currently, but there's already a couple of other tools that have committed to and started to support it. And although it's a JSON document, the reason we decided on JSON was because it's really easy to use, but also it's easy to incorporate into any other tools. It's easy to write tools for. You can write code generators for it very easily. But when it was implemented in Zap, the decision was made to implement it as a GUI. So rather than having to go out of your way and define all of these new separate web tests, you can actually do your normal manual testing, right-click in Zap, and then save it, create a Zest test case, and edit it with a GUI. I'll show that if I have time at the end. In addition to that, we also make heavy use of a bunch of other frameworks. We use Skipfish and NetSparker to do some basic web fuzzing. And then we also use some tools that, one of the advantages to using new technologies is you get to discover bugs in how things work. So we have, in addition to doing a pile of different types of automated testing for both web and platform applications, we also make heavy use of manual code review processes. Any code that might touch a sensitive area of Firefox, or any code that's coming actually any code that goes into Firefox gets reviewed by somebody. But in addition to that, we have dedicated module owners who are either responsible for reviewing code or assigning people to review code. In addition to that, anything that goes into our web applications that might have a security impact is also reviewed by another team member before it gets checked in. But we've also been making heavy use of some static analysis tools. So we use Clang as part of some of our build processes in order to identify areas that need to be addressed. But in addition, we've recently started using Coverity Scan Ladder. We used an older version of it. We didn't get very good results, but we have been recently reevaluating it along with some other third-party tools, and they've actually improved quite dramatically in the last little while. So we also, one of the things that my team is also responsible for, and anybody who deals with this will know exactly how that feels, we do third-party reviews. And I've been doing third-party reviews as part of my responsibilities in security pretty much since I got involved with it. And this is pretty much sums up my experience with it over the last decade. So we basically, one of the things that we do at Mozilla is, in order to keep ourselves lean, we rely heavily on cloud service providers. We rely heavily on third parties to things like HR and legal support, as well as in order to make sure that we're not focusing too heavily on things that are outside of our mission. When it comes to building technical demos, like the browser quest one that I showed you a little while ago, that was actually built by a third party that we hired. We said, we want to have this, and we want to make this kind of a thing. So rather than trying to build a game development studio in Mozilla, we just went out to some developers who had been building web games and got them to build one using pure HTML5. So from a third-party review perspective, it's a little bit different because in most cases where a company does a third-party review against a different service provider, basically since the release of Sarbanes-Oxley documentation or payment card industry compliance stuff, you've had to do it in order to show that you're actually making sure that you're doing due diligence. For us, it's more about making sure that they're actually not going to violate our principles. So we've had some interesting scenarios where we've had business units that have gone ahead with a project and set up contracts and moved full steam ahead, and then they hit the roadblock that, oh, well, you want to ship data over to them? Let's do a review. And the really cool thing about Mozilla is that where we found problems and the vendors are completely unwilling to fix them because they don't consider it to be a significant risk, we've actually backed out and not progressed with the project. The notion of accepting business risk at Mozilla is still there. It's prevalent in any organization, but because the people who run Mozilla at the most senior level are the people who founded Mozilla and who defined those initial principles, when we actually communicate effectively and show them that this is the case, we're able to drive really effective change in how we address some of those things. Moving off of application and third-party vendors, we also have operations security team. And this is something that's really challenging because we don't have bring your own device in the sense that some organizations are starting to adopt it, but we do have an environment where, in addition to our employees and all of the hardware that we provide them, we have thousands, actually tens of thousands of different people that contribute in different ways to Mozilla web properties, Mozilla products and services, and we don't have any control over their devices. We don't have any ability to dictate any kind of security requirements to them. In fact, the only thing that we can do for many of our contributors is say, your Bugzilla password has to be this long or this complex so that you can actually access it, or you have to use this length of an SSH key so that we can verify who you are when you're trying to make commits to a repository. So we have a dedicated infrastructure security team that works on things like all the antivirus, firewalls, network security monitoring, as well as handling all of the typical business and user data considerations that we have. But we also have them working on building out new ways to support the community. And one area that we've kind of been looking into a little bit more is how we can extend some of those capabilities to be able to provide monitoring and to help support the security of our end users that are not just people who are within our organization, but also people who work as volunteers, provide their own infrastructure and hardware, and we want to be able to do that in a way that keeps it open and also is respectful of our volunteers' privacy. So we want to help them to figure out what indicators of compromise they might have on their devices, let them know if we think there's a problem, but without, being all NSA-like and capturing all of their data and hoovering it off to a data center. So the operations security team has been doing some really interesting work around that. And in addition to that, because of the focus on some of the lower level operation security stuff that that team does, some of our team members from our OPSEC group have been working with our Firefox OS team to make sure that in addition to all of the application layer controls that we're building into the Firefox OS operating system, that the underlying Linux layer also has modern exploit mitigation techniques built into it. So all of the typical mandatory and access control policies and role-based access control policies that you'd want to see if you were trying to harden a desktop device, we're trying to implement within a mobile device, which is challenging because it has performance implications and it makes writing some parts of the operating system a little bit more difficult, but so far it's been pretty successful. From the security engineering side of things, this is our team that focuses on building new security technologies into the browser, although we're looking to expand that into building new security technologies for web applications as well. Right now, the biggest contributions that our security engineering team has made over the last little while, this is the group at Mozilla that came up with content security policy. If you're not familiar with it, it's basically the easiest way to describe it is as a HTTP header that configures a content firewall within the browser so that you can actually specify how websites can load content from third parties or whether they're even allowed to at all. And properly used, content security policy can completely prevent any kind of reflected or stored XSS attack, although DOM XSS is still possible. It doesn't do anything for DOM XSS at the moment. It's pretty much the only way that we are aware of that you can actually stop XSS from being a problem, even if you're not worrying about even if you're not worried about user input. So This is, if you're interested in it, there's a bunch of documentation on the Mozilla website. It's also been adopted as a standard and implemented in Chrome, and I believe in Safari as well. I don't believe it's shipped in Internet Explorer yet. We also have some folks who are working on DOM-Crypt and the Web Crypto API. And we've also recently shipped improved support for iframe sandboxing in Firefox. Very recently, we made the change to implement mixed content blocking. So this is a pretty basic feature. It would be cool to say we were first movers on this, but the credit for that actually goes to Safari. They blocked it a long time ago. And it's something that has started to have an impact. And the really interesting thing is that from a user perspective, they don't notice until things stop working. But we immediately started to see responses from some major websites in different areas that they actually blamed a problem in Firefox for mixed content blocking, and were advising their users to turn it off, at least for that the site that wasn't working. So it's definitely indicative of some of the challenges in trying to implement new browser security features. In addition to that, the security engineering team did the software development heavy lifting behind the Do Not Track header, which wasn't overly complex, but in terms of kind of trying to set the stage for a larger discussion about internet tracking and how users perceive and communicate their privacy wishes, it really opened a new chapter in discussing how online advertising works and whatnot. So that's what our security engineering team does. So I'm going to jump back to an area that's really important to me at Mozilla. Ever since I started at Mozilla, I've been focused on building better tools for automation. It's why we started working on Garmer. And it's one of the really powerful, flexible tools that we used heavily even before we started implementing Garmer was Zed Attack Proxy. So this is a really straightforward intercepting proxy. For people who haven't used it, it's an open source project published by OWASP. And the developer, as I mentioned, works on my team at Mozilla. Just takes a minute to start up. I know somebody earlier was talking about the fact that you should never need a Java program. I disagree. Java is actually a really powerful and flexible framework. I just don't believe it belongs in the browser. So it's just going to take a minute for Zap to load up. But in addition to being an intercepting proxy, it has several different fuzzing frameworks built into it. And it has some integration points around using FuzzDB, which is a collection of features or parameters and signatures for how you can implement a fuzzer that's maintained by a different member of my team named Adam Mutner. So it currently has support for WebSockets, and it also has a Zest implementation built in. And our window. So this is the current user interface for Zap. It's changed a fair bit over the last little while. If you haven't tried it out recently and you do web security testing, you should probably give it a go. It's also something that we use for Minion. And this is not loading over there. There we go. So Minion is a platform that I have been working on. It started off as a collection of shell scripts. And at one point, I had the idea that someday I was going to go off and start a startup. And then I joined Mozilla, and I realized that startups are a lot of work, and I really like working at Mozilla. So I was talking with my manager one day, and I was like, we should really build this automated security testing framework and make it open source and do all of this cool stuff. So we basically hired an intern, and a guy by the name of Matt Fuller wrote the proof of concept. So he got some support from some of the developers in our group, and we released an initial, not very effective version of Minion at AppSecUSA in 2012. And then shortly after we did that, a guy named Stefan Arentz joined my team, and he started working on Minion full-time. And let me just load it up here. So what Minion is an open source security as a service framework. And the internet's no good right now. Sorry about this, give me a minute. There we go. So it uses Persona to sign in. It's an open source project. And all you have to do is, well, we don't actually provide access to our production instance to anybody other than Mozilla community members. But it takes about 5 or 10 minutes to get set up on any Linux or Mac OS box. And it uses Persona, although Persona is a federated identity protocol, it has some privacy preserving principles. So if you stand up your own instance of Minion, and you use an email address that is not a Mozilla.com or Mozilla.org email address, we actually have no control over the account system. So it's actually a very flexible and powerful way to handle authentication. It's just taking me a minute here to log in. There we go. Okay, and so the focus of this tool is to create a mechanism so that developers can run all of the different security tools that we use on a daily basis in the security team without having to become security experts themselves. Now, because this is the size of this window, it's actually showing me the mobile interface, which is very similar to the normal interface. You can actually, it has a full administration and access control management system. And the way that Minion works is, rather than trying to create a new security tool, we decided to build out a bunch of different mechanisms for automating security tools. So Minion is, at its core, a task engine. So it handles scheduling, it handles moving information around between the different plugins that exist. It has a replaceable front end, and it also has a mechanism for communicating with plugins that can reside anywhere on the network. So you can actually very easily break Minion apart and have all of the plugins residing in a trusted network and have only the information from those plugins being passed back and forth. And the plugins themselves can be installed anywhere. They can be written in any language. All they have to do is support a very straightforward JSON API so that you can communicate with the plugin server itself. You can either use the plugin server that we wrote in Python, or you can implement the support for the API directly within a tool, which is, currently Zap support for Minion is implemented as a plugin, Python wrapper. But as we stabilize the API for Minion, the intention is to write a Zap extension so that it'll be running the plugin infrastructure directly within Zap itself. So we actually have a whole pile of different plugins that we've written for Minion that support different things, but we have support for Skipfish, we have support for Zap, we also have support for Nmap so that we can do basic service discovery and whatnot, and these are all configured through plans that can pass different configuration options based on the different tools that you're using. It's also designed so that you don't have to go in and do heavy-duty user management. You don't have to, when you want to create a user, all you have to do is go into the invite system, set a group that you want them to have access to, and you can send somebody an invite to be able to use the system. So the intention is to create this as a platform that we can use at Mozilla, but one of the first considerations that we had was, how can we make this so that anybody can use it, and how can we make it so that it's easy for people to use? So the initial approach that we went with was to ship a VM that had a copy of Minion running within it. The problem that we found is that maintaining a VM that is used as a distribution is actually quite a lot of work. So Stefan simplified the install process, so it's extremely easy. When I went to install an instance of Minion for a talk that I gave previously this week, using hotel internet connection and running in a VM on Windows, it only took me about 9 minutes to install. So it's really straightforward, doesn't require a whole lot of configuration, and from an ease of use perspective, let me just get back to the core interface. Once you have things set up, all you have to do is actually just go in and you can take a look at all of the different sites that a user has access to, and kicking off a new scan is as easy as hitting the scan button. it starts to immediately give you feedback. And because this is a production instance, I'm not actually going to dig into any of the results on our production services, but I will go into some of these demo sites. Or actually, I'll go into this one. I don't know if you've heard of canary.pw. One of my friends in Vancouver wrote a service that basically scrapes all kinds of different paste bins, indexes the results, and allows people to search them. It's kind of a neat thing. He also gave me permission to run Minion scans against it. So because of the fact that we're focused on privacy and security and making sure that we want all of our applications to meet our requirements, the scorings are probably different than they might be for a different organization. But in one of the upcoming releases, you'll actually be able to change the scoring of vulnerabilities based on your company or organization's priorities. But we have things like the X-frame options header missing being a high criticality issue because that's a requirement for our applications. On the other hand, the fact that we can talk to the server, that's informationally. If you can't talk to the server, there's not much use in trying to scan it. But it basically shows the different results. And if you, these are results that are coming from tools like Nmap, from Zed Attack Proxy, actually this particular scan doesn't run skipfish, but these are just normalized results. But you can actually drill down and get access to the results files from each of the individual scans that were performed. So there's no loss of data here. If one of our developers comes up and says, I don't understand why I'm getting this STS issue, strict transport security issue, because we're emitting the header, I can actually go in and get the results, find out what's going on with the scan, and make sure, first of all, that the developer understands the issue that he reported, and also find out whether or not there's a bug in our software and fix it. So this tool is something that's being used by some of our QA folks, some of our web developers, and a bunch of our community members. And it's also something that we're investing heavily in terms of development. The core Minion framework is being extended to, I'm working on an extension for it called Cohort that will allow the automation of static analysis tools. So you'll be able to point, instead of scanning a website, you can point it at a repository and start getting results in Python. And eventually we'll extend that to JavaScript as well. We have a privacy project that we're hoping to launch next quarter called Constellation that uses the Minion infrastructure and make some changes to the plugins that we're using to be able to implement privacy scanning for websites to check for things like cookie header compliance, all of the different kinds of privacy requirements that are being imposed all over the world. So those are some of the things that we're working on from an automation perspective. Let's get back to... So the Minion, as I mentioned, Minion itself is an open source project. If you go to github.com/Mozilla/Minion, you can grab all of the information about deploying it. And if you are interested in testing it out, I do have a test instance that I can give people access to. But I do expect you to prove that you own the site before I let you scan it with my infrastructure. There's some other stuff that I can show off from a tools perspective. But before I do that, are there any questions? About anything, also about anything related to Mozilla, I'm happy to answer any questions you might have. Firefox, anything like that. Okay. Any particular things about the software that I was showing that you'd like to see more of? Okay. I'm going to go get a beer now then. Thanks for your time. Actually, there is something else I'd like to say. I moved away from Winnipeg in 2007, and when I left, the last security event that I went to was largely dominated by vendors, and it's really cool to come to a security event here after a few years and see that there's actually a security community here now that's not just focused on selling products and stuff. So it's really awesome work by the Skull Space folks and the people that are involved with BSides on putting this together.